Hello everyone, welcome to our first physics class. Today we'll discuss the topic relative velocity. This is a daily phenomenon which you all experience, especially when traveling in the vehicle. Have you ever wondered why vehicles approaching you on the opposite side appear to travel faster? Yes, this is relative velocity. Let's dig into the meaning and practical applications. Relative velocity of a body A with respect to body B is the sum of the velocities of A and that of B reversed. Emphasis is on reversed. This means that the velocity of B is negated. Now, relative velocity is never a real value. It is always apparent. It becomes the true velocity of A only when B is considered to be stationary. That is, when B is not moving. So how do we represent this mathematically? Let a symbol VA represent velocity of A and a symbol VB represent the velocity of B. Then velocity of A relative to B given as VAB equals VA minus VB. The minus sign here shows that the velocity of B has been reversed or negated. Similarly, VBA will be given as shown. Now, unless otherwise stated, we assume both bodies to be moving in the same direction. This is so to make calculations very easier. Let's look at practical applications of relative velocity in daily life. To begin with, the first case is when both bodies are moving in the same direction. As shown in this diagram, body A and body B are all moving in the east. Now, by convention, we give eastward to be positive and westward to be negative. Similarly, we give north to be positive and south to be negative. VAB, which is velocity of A relative to B, is given as VA minus VB. The second case is when both bodies are moving in opposite directions. This is what we usually observe when our vehicle is approaching another vehicle in the opposite direction. In the diagram, body A is moving in the east and body B is moving in the west. So then by conversion, body B has negative velocity. Then velocity of A relative to B, which is VAB, becomes equal to VA minus VB. The minus sign here shows that B is traveling in direction opposite to that of A. Hence VAB becomes equal to VA plus VB. Let's look at the third case. For the third case, that is when the velocities are inclined to each other. As shown in our diagram, body A is moving eastward and body B is moving southward. These velocities are inclined at an angle of 90 degrees to each other. Now, the resultant velocity becomes the relative velocity, and in this case, the triangle has to be completed. That the triangle of vectors has to be completed, and we usually apply the cosine rule, but you know the Pythagoras theorem is a version of cosine rule where the angle of inclination is 90 degrees. So for our diagram, velocity of A relative to B by Pythagoras theorem becomes VAB squared equals VA squared plus VB squared. Then VAB becomes equal to square root of VA squared plus VB squared. Let's consider some solved problems. Our first question reads as: two cars A and B move with velocities of 40 km per hour and 60 km per hour respectively. Find I. Let's start. First of all, you capture the data, and I here we want a velocity of A relative to B, that is VAB. We assume both bodies are moving in the same direction, as nothing about direction was mentioned clearly in the question. So both moving in the eastward direction. Then VAB becomes equal to VA minus VB, which is 40 minus 60. Then we get minus 20 kilometers per hour. So practically, this means that for a person in body B, car A is traveling at a velocity lower than the actual velocity of 20 kilometers per hour, and also it appears car A is receding. To the second part of the question, where we are supposed to find VBA, we get VB minus VA, which is 60 minus 40, giving us 20 kilometers per hour. This means that to a person in car A, car B appears to be traveling at a velocity lower than natural velocity of 20 kilometers per hour, but is still moving in the eastward direction. Now, for the third part of the question, which is velocity of A related to a stationary observer, the stationary implies that velocity becomes zero. Hence, VAO, which denotes velocity related to the O, becomes VA minus VO, which is 40 minus 0, and gives us 40 kilometers per hour. This means that to a stationary observer, car A appears to travel at its real velocity. We explained this case in the earlier part of the lesson. Now, question 2 says that body A moves velocity 50 kilometers per hour due north, whilst B moves it 80 kilometers per hour due south. Determine the velocity of A relative to B. Let's take note of the direction. This tells us that both bodies are in opposite directions. Hence, VAB becomes equal to VA minus VB, which is 50 minus 80 kilometers per hour. The minus 80 means that B is in the direction opposite to that of B. And then we get VAB to be 50 plus 80, becoming 130 kilometers per hour. So car A appears to be actually traveling faster, which is not a true velocity. Let's look at the third question. Alright, the third question reads as: a man rows a boat in still water at 8 kilometers per hour, wishes to row due north across a river 4 kilometers wide flowing at 3 kilometers per hour due east. Calculate I and II. So from the question, the first thing to do is to capture our data. Over here, the velocity of the man is 8 kilometers per hour, and the velocity of the river is 3 kilometers per hour, and also the width of the river is giving us as 4 kilometers. Now we can draw a triangle to represent this motion, where VR points towards the east, and then also we have, since the man wishes to cross due north, he must take a direction at an angle to the bank. By this, the impact of the river will get him to a position directly across the river. So now by the diagram over here, we can see that sine theta will be calculated as VR over VM, since sine theta is opposite by hypotenuse, and that gives us 3 over 8, and that gives us 0.375. Then also theta becomes equal to sine inverse of 0.375, which gives us what? 22.02 degrees. That means that the man must turn in direction of north 22.02 degrees west. Now let's go to the second part of the question. The second part of the question, we have to find the component VMR, which is the actual velocity of the man relative to the river. We apply Pythagoras theorem, where Vm squared will be equal to VR squared plus VMR squared. That means that VMR squared will be equal to Vm squared minus VR squared, and then VMR becomes equal square root of Vm squared minus VR squared. So you put in the values for Vm of 8 and VR2 of 3. That gives us 7.42 kilometers per hour. Now we know that velocity is giving us distance over time. That means that time will be equal to distance over velocity. And distance here is the width of the river, which is 4 kilometers. And velocity here is VMR, which is 7.42 kilometers per hour. This gives us time of 0.54 hours. It means that the man spends 0.54 hours to reach the other bank of the river. Hope you have understood everything. Congratulations on making it to the end of the lesson. I've included just 2 practice questions for you to try your hands on, and the answers are captured in the parentheses. So this will be for question 1, and this one too for question 2. Please don't forget to like, comment, and subscribe to my channel. Also, kindly share among your friends, and I'm open to any question at all. precisely for the WASI and NOVDEC students. Please make it a point to join me again for my next lesson. Thank you.